So after going over many lessons, even from the past where we saw getting 0 over 0 for something, and throughout our other lessons of maybe trying to do infinity minus infinity or infinity over infinity or anything like that, or we were doing 0 times 0 and I warned you don't do 0 times infinity. All of those things are indeterminants. Every time we got those expressions, I should say, because they're not exact values, I said, hey, wait, that's an indeterminate. So in our do now, we copied some of those indeterminants, and some of them I just said, so I'm just kind of giving you all the variations that you can see. These are all considered indeterminants. You have a negative infinity times 0, infinity minus infinity, 1 to the infinity power, 0 to 0 power, and infinity to the 0 power. Alright, so why I bring this up is that as we explored all our lessons, and maybe some more of these came up instead of just like our usual 1 or 2, when we have to do limits, sometimes these come up as well. And so there's a way in which we can still figure out the limit of a function if one of these turns out to be the expression when we're trying to find its limit. So let me get the slide here to the left. Give me a second. I just want to erase this. Okay, here we go. So suppose you have a function, okay, and if you plug a in it, it gives you 0. And you have another function, okay, a different one, and you plug the value of a in, and you also get 0. However, you do know that the derivative for f exists, or f prime of a exists, and g prime of a exists. Okay? You also know that g prime of a is not 0, then finding the limit of f over g as x approaches a, this may not be done, okay, by direct substitution, because as it's saying in the example, we would get 0 over 0. That doesn't tell us anything about our limit. The limit would still exist. But a way in which we can find that limit is by taking f prime of a, whatever value that is, and dividing it by f prime of a, which would also have some value but not equal to 0. And that's it. And then we'd end up with our answer. Okay, so that pretty much explains what we can do for what's called L'Hopital's rule. Okay, so you may see in newer textbooks they actually changed it to L'Hopital's rule. It is originally L'Hopital's rule. It is for a mathematician. I think that it just started to be commonly misspelt, and because it became so common, they started to type it in newer textbooks. So, let me get back to our notes here. Hopefully you had enough time to get that down. The stronger form. Okay, so this is just like a formality when you have to do L'Hopital's rule. So we know that the limit of f of x over g of x as x approaches a would give us 0 over 0 by direct substitution. So that doesn't work, and we still don't know its limit. So what we would do is we would take the limit of f prime of a over g prime of a as x approaches a. So what this is basically saying is that we're taking the limit of this, which is a constant, and we're dividing by the limit of that, which is a constant, and That's essentially a stronger hold once we use the properties of limits to proclaim our answer than if we were just stating the derivatives. Okay, so let me get to some examples. Okay, please get down number 1. So for number 1, the first thing I want to do is show you that if we do direct substitution, wherever we see x, okay, now I have that. Then we get 1 minus 1 in the numerator, which is 0, and 0 plus 0 in the denominator, so that's 0. So you can see how this does not help us finding the limit. Okay, the limit does exist, so let's get to what we should do here by doing L'Hopital's rule. We're going to use the stronger form. So that means that I want to take the limit of my numerator and the limit of my denominator. But I'm taking the limit of not just the numerator of what it is right now. I misspoke. I was jumping ahead because I get excited. Who can't? I want to take the limit of the derivative of e to the x minus 1, which would just be e to the x. And I'm keeping as x approaches 0. Now for the denominator, I'm going to take the limit of the derivative for x squared plus x as x approaches 0. The limit of the derivative of x squared plus x is 2x plus 1, and we're going to keep as x approaches 0. So at this point, if we try to substitute, do that direct substitution, we're going to get 1 in our numerator, and we're going to get 1 in our denominator. So we don't have an issue like we had before, and that means that this answer equals 1. I ran out of space, so I'm drawing an arrow here. Okay, so just a note, it worked the first time. Okay, note. Use as many times as necessary. And I usually get students say, well, does that mean we have to do it 12 times? No. Usually if it's not working, after a few times, maybe 3 times, even perhaps 4 times, I would say stick with like 3. See if there's a pattern or trend. Usually, if there's a pattern or trend that you're still getting infinity, or you're still getting 0 in the denominator or the numerator, if you see that happening, then you're probably not getting anywhere with its limit. If you see that your numbers are like decreasing, that means it may end up becoming 0, or perhaps eventually it'll stop before it's 0, depending on what x approaches. So just determine it that way, and perhaps you'll be able to justify if there needs to be 3 times or 12 times or whatever. Usually for these AP problems, you're not going to be doing it 12 times. So let's get to number 2. So for number 2, we see a different problem. It's different not because I didn't give you a fraction or you didn't see a polynomial expression before, you did in number 1. It's because x now approaches infinity. You can still use L'Hopital's rule, as long as it's the fact that you're getting an indeterminate in the first place. So let's see. In the numerator, infinity plus 1 is still considered infinity. And in the denominator, 3 times infinity minus a little 4 is infinity. So this is one of the indeterminates I was pointing out to you before. So yes, we're going to try to use L'Hopital's rule. I say try because sometimes it doesn't work. So little heads up there. That's why, again, I said in the last one, use as many times as necessary. See what it's giving you. Okay, so here we go. The limit of the derivative of my numerator. If I take the derivative of x squared plus 1, it's just 1. I'm doing it as x approaches infinity. And for the denominator, it's going to be the limit of 3 as x approaches infinity. So by doing that, we end up with 1/3. And you know what? That means the answer here is 1/3. Okay, so it also worked out the first time we did it. If it doesn't, just try to do the derivative of this again and this. Okay? Once you get an answer like 1/3, yeah, you got it. Don't keep doing it because then you get the limit of 0. That won't work over a 0. That, again, it doesn't work. So hopefully I addressed a lot of different questions and issues you might have when you're doing this. Please start doing the practice. Let me know if there are any questions or issues that you still have with this rule for right now. Okay, good luck.